Hello, my name is Viha Kothakonda, and today I'm going to be talking about the inheritance of Huntington's disease based on family history, genetics, and environmental factors. So, a quick introduction to what Huntington's disease is. Also known as HD, Huntington's is a neurodegenerative disorder, which basically just means that it causes the gradual degeneration of brain cells. The inheritance of Huntington's disease is through the parental genomes, and the only cause for Huntington's disease is inheritance, which basically means that somebody with Huntington's can only get it if their parents are a carrier and they pass it down to their offspring. Huntington's is typically adult onset, which means that most people who have Huntington's disease will start to experience symptoms in their midlife, so around their 30s to 50s. And after diagnosis of Huntington's disease in this time frame, we have an average lifespan of around 10 to 30 years. So unfortunately, Huntington's disease is fatal, and there is still current research going for treatments for Huntington's. There's a wide variety of symptoms that come along with Huntington's disease. We have physical symptoms like chorea, which is also just known as like uncontrollable limb movements that may or may not harm the individual with the disease. Then we have things like cognitive drop in ability and a drop in mental ability as well, loss of communication skills, mood changes, memory losses, etc. My research question when I was conducting my research was, how does family history determine the severity of Huntington's disease in patients? So I focused on genetic factors that can affect a patient's severity of the disease, and economic and socioeconomic and environmental factors that can change how a patient's likelihood to develop the disease. Some background and significance specifically on how Huntington's works on the genetic level. So, the typical Huntington's disease is speculated to be essential to brain development. So, the protein that is created through the non-mutated Huntington's gene is involved with transcription and transport in cells. And this is necessary for our brain to function properly. And so, when we have a mutation on the Huntington gene, specifically the CAG triplet repeat. So we have a triplet of nucleotides, the CAG triplet, that is repeated several times. And if these repeats occur too many times, then we have Huntington's disease develop as the gene does not no longer codes for the protein properly. The protein will no longer be produced properly, and this transcription and transport in cells will no longer be carried out properly by the body. Huntington's disease is an autosomal dominant inheritance pattern, which means that at least one dominant allele is needed for a patient to be affected. This also essentially means that only one carrier or one affected parent is needed for a 50% chance of inheritance. So, families with Huntington's disease will likely see it passed down to their offspring, as it is not a recessive inheritance pattern. So we have things like genetic modifiers, environmental differences, and majorly mutation varieties that are significant to an individual's inheritance of the disease. My methods for this paper was a literature review. So to make this paper, I collected articles from across different scientific journals as well as Google Scholar. And I compiled this information to kind of create my own paper as well as create my own individualized outlook on how I think the future direction of Huntington's disease research will go and how we can use this information to kind of propel this research in a different direction. So getting into my findings, focusing on the genetic factors first that I found, one of the biggest genetic modifications or one of the biggest like genetic variables that I found within Huntington's patients that can affect somebody's inheritance of the disease or how severe their inheritance of the disease is the length of the repeats. So we know that too big of a repeat can cause the disease, but what individualize on the more individual level, we can see that different amounts of these too long repeats can change how severe somebody's inheritance is based on their age of onset, so and their risk of passing the genes on if they were to have offspring. Less than 27 CAG repeats is seen as typical, so no mutation there. 27 to 35 means intermediate alleles. What this basically means is that the person has no risk of developing the disease and they won't develop the disease. But their offspring does have a chance of developing the disease if those intermediate alleles decide to expand during the process of the offspring being generated. 36 to 40 repeats is a risk of development, so the individual might develop the disease, they might not. And over 40 is definite inheritance, which means that the individual will 100% inherit the disease. What's not on here is 50 plus, which is a lot more than typical. And this is very rare, but in these cases, we have a change in the age of onset. So in these cases, we see juvenile and infantile onset patients. They start to have symptoms a lot earlier in their life as compared to these adult onset patients who start to see symptoms around their 30s to 50s. We also have genetic modifiers, which have a possibility for a small impact. There have been genetic modifiers that were researched, like the TAA repeat on GRIC2, as seen here. This one specifically didn't show much result for the impact on Huntington's disease, but genetic modifiers are essentially different parts of the genome that can affect the way that this part of the genome works. So a more effective way to look at this is genome-wide searches, which a lot of researchers have been employing recently. Basically looking at the entirety of the genome to look for these possibilities instead of focusing on one genetic modifier. And this process is a lot more efficient and may have some promising possibility for the field of Huntington's disease research. Additionally, there's been some correlation between socioeconomic factors and environmental factors and the Huntington's disease rates. We see lower income households have higher Huntington's disease rates, and higher income households have lower Huntington's disease rates. And this is likely because this correlation is likely occurring because these households with higher Huntington's disease rates are comprised of individuals who may lose their job or lose a source of income as the disease develops and symptoms worsen, therefore creating a low-income household and continuing a cycle as they develop, as if they have offspring, as the offspring develops the disease and continues to live in a low-income household, this is why we see more prevalent rates of Huntington's in lower-income households. There's also higher rates of HD in certain countries like Scotland, England, Venezuela, and Tasmania, and lower rates of HD in African, Black, and East Asian populations. There was also quite an interesting predictive study in Victoria, Australia, over 15 years with 756 participants that were thought to be at risk of Huntington's disease. And it kind of tied together all these important variables that I just discussed, like genetic variables, like the length of the repeats, as well as environmental variables, such as prior HD exposure. So like if they were to have a family member that had Huntington's disease, how would that affect their willingness to get tested? And it kind of brought all those factors together to create like a hypothesis on why certain individuals exposed to certain things might be more prone to inheriting the disease than others. Some future directions, we see a big gap in research. As I was doing my research, I noticed this particularly. There tends to be a focus on finding treatment for the disease in the Huntington's disease research field. And I think that and while this is very, very important, I think that we can also shine a bit brighter of a light on the inheritance of Huntington's disease to kind of bring more awareness about it and improve diagnosis rates, because improved diagnosis rates can also decrease suicide rates, as suicide rates are seen to peak in Huntington's patients right before diagnoses are given. So I do find that quite important. I think that there are also a lot of future prospects for the development of treatments, because there has been individualized therapies that are researched, there has been improved diagnosis rates, more effective treatments, and even recently a UK study found that there's promising gene therapy that can slow down the progression of the disease by 75%, which can allow somebody with Huntington's to live for quite a long life. These are some of my references. And I would just like to thank my mentor, Theana Johnson from Oxford University, for guiding me through this paper and helping me do this research. And I'd like to thank Lumiere Education for making this research possible through all the opportunities and support that they have provided. Thank you.